Have you ever experienced deformation in parts built with a metal 3D printer? In the powder bed fusion process, a laser melts metal powder layer by layer. However, immediately after melting, the material is rapidly cooled, creating a steep temperature gradient. This results in a thermal stress due to shrinkage, and when this stress accumulates, it can cause warping or even cracks in the part. This phenomenon is no exception for Matsuura's hybrid metal 3D printer LUMEX. In particular, when building precision components like molds, an area where LUMEX excels, warpage-induced dimensional inaccuracy leads to additional post-processing and thus higher manufacturing costs. Now, take a look at this part. It was built on a thin base plate without any consideration for build conditions. Let's place it on a surface plate to see how much it has warped. As you can see, it spins easily. That's how much it's warped. To prevent this, we typically use a thick base plate to physically suppress the warping forces. However, increasing the base plate thickness based on the part size limits design flexibility. To overcome this challenge, Matsuura has been developing technologies to enhance the accuracy of 3D printed parts. Take a look at this next sample. It may look identical to the previous one, but when placed on the surface plate, it doesn't spin. That means the warping has been significantly reduced. The key lies in the optimized build conditions. By carefully adjusting those parameters, higher precision can be achieved without relying on thicker base plates. In this way, Matsuura is actively working on solving the inherent challenges of metal 3D printing. If you previously gave up on metal 3D printers, today's latest technology may be the solution you've been waiting for. We invite you to experience the power of LUMEX through our LUMEX production services.